Good morning, grade 7. Hope you are all doing well. This is Miss Pamela giving the physics course. Today we are going to continue chapter 5, section 1. What is energy? If you can all please open your books on page 149 so you can follow up with me. So in the last video that you received from me, we talked about the first basic kind of energy, that is kinetic energy. We talked about the factors that affect kinetic energy and how to calculate kinetic energy. Today we are going to continue the section and talk about the second basic kind of energy, which is potential energy. Potential energy is stored energy that results from the position or shape of an object. This type of energy has the potential to do work. So an object does not have to be moving to have energy. For example, when you lift a book up to your desk, you transfer energy to it that is stored and can be used later. So not only moving objects have energy, also objects at rest. Whenever you lift an object or exert work on an object, you transfer energy to this object. This energy can be stored in the form of potential energy to be used later on. For example, when the object falls back to the ground. We have two kinds of potential energy. The first one is elastic potential energy. Elastic potential energy is the potential energy associated with objects that can be stretched or compressed. So whenever an object can be stretched or compressed like a spring, it contains a stored energy called elastic potential energy. For example, when an archer pulls back an arrow, the bow changes shape, as you can see in the figure in front of you. The bow now has elastic potential energy because it changed its shape. Please pause the video for a minute and see figure 4, page 150. Read and answer the interpreting question. The answer is that the stored energy will be transferred to the arrow. So whenever the archer pulls back the bow, he changes the shape of the bow. Thus, he transfers energy to the bow that is stored in the form of elastic potential energy. This energy is later on transferred to the arrow. The second kind of potential energy is called gravitational potential energy. It is the potential energy related to an object's height. For example, when you sit at the top of a slide, like in the figure you see in front of you, you have gravitational potential energy due to your height above the ground. In order to calculate gravitational potential energy, we use the equation shown in front of you. Gravitational potential energy is equal to weight times height. Energy is measured in joules, weight is measured in newtons, and height is measured in meters. So as we conclude from the equation of gravitational potential energy, two factors affect this energy. The first one is weight. As weight increases, gravitational potential energy increases as well. The second one is height. As height increases, gravitational potential energy increases as well. So the greater the weight, the greater the gravitational potential energy. The greater the height, the greater the gravitational potential energy. Please pause the video for a minute and see figure 3, page 149. Read and answer the interpreting question. The answer is, the red skier has more gravitational potential energy on the higher jump because gravitational potential energy increases as height increases. By rearrangement of gravitational potential energy's equation, we can calculate weight if we know gravitational potential energy and height. So the weight of an object is equal to the gravitational potential energy over the height of the object. Weight is measured in newtons, height in meters, and energy is in joules, of course. Also, by rearrangement, we can calculate the height of an object if we know its weight and gravitational potential energy. So the height of an object is equal to gravitational potential energy over weight. Height is measured in meters, energy in joules, and weight in newtons. Example. What is the gravitational potential energy of a 50 newtons bird flying at a height of 3.2 meters? Solution. Gravitational potential energy is equal to weight times height, equal to 50 newton times 3.2 meters, equal to 160 joules. As a homework, please solve the following sample problems. What is the height of a boy having 300 joules of gravitational potential energy if his weight is 637 newton? Number 2. What is the weight of a box having 50 joules of gravitational potential energy when it is 1.9 meters above the ground? In addition to the sample problems, solve number 2, parts A, B, and C, page 150. Please, you have to be done with the homework on Thursday, 26 March, and send it to me on my number. Thank you and good luck.